Hello everyone and welcome to my channel. So for today's video we're going to look at this question, which is question 5. We'll start with part B. Part B says state two conditions for the body in equilibrium, or basically state two conditions for equilibrium. So part B, so the first condition for equilibrium is that the summation of all forces that are acting on a body has to equal 0. Okay, so the first one. The second one is the summation of all the moments that are acting, all the moments on that body has to equal 0. So when it comes to the summation of the forces, it is important to note that summation of all forces is broken down into summation of all forces in the x-axis and summation of all forces in the y-axis has to equal 0, like that. Okay. The second, the part C part says the cylinder is hung from the end A of a non-uniform bar AB as shown. Okay, so that is the non-uniform bar. Then it continues here to say an object X, is this one here, is hung from end B. The weight of X is adjusted until the bar is horizontal and in equilibrium. Calculate the weight of X. Okay, so for this one, we can draw the bar. Just move this a bit up. So let's draw the bar and the forces that are acting. So we have a force at this point. We can call this one point A. Let's label this one point A. So we have a force at that point, which is 0.60 newtons, and we have another force somewhere here, which is 0.25 newtons. Then we have point P. Okay, let's have point P there. So point P, and we have X here. So let's have our X. Okay, so this one here is also going in this direction. It's also acting downwards. Okay, and we know that here we've been given 12 centimeters, which is the distance here. And since from point B here to this point where I have that force, we have 20. We can just subtract 12 from 20, then we'll be able to get 8 centimeters here as our distance. And from point B to point A, or the length or span of the beam is 50, meaning we will remain with 30 at this point. So 30 centimeters, which is this one here. Okay, so point P, let's write point P here. Okay, so now for us to find X, we have to use the principle of moments, which is the summation of all moments has to equal 0, meaning the clockwise moments have to be equal to the anti-clockwise moments. So here we say taking moments at point P, so taking moments at point P, which is this point here. So we know that from, if we take moment at point P, this moment, let me use a different pen, this force is trying to turn this body in this direction, and also this force is trying to turn this force this body in that direction, or in the anti-clockwise direction, and this one here is trying to turn in that direction, in the clockwise direction. So we're going to take clockwise moments to be negative and then anti-clockwise moments to be positive. So if we use the principle of moments, so we say a summation of moments, since the beam, we're saying the beam has to balance, so we want to find the force X when the beam is balanced. So the summation of moments has to equal 0, meaning we're going to start, let's start with the moments to the left hand side. So we're going to have the moment for this force, which is 0.25 times 8, because that is the distance between the axis of rotation, or the pivot, and the force. So we're going to have 0.25 times 8. So the 8 centimeters has to be converted to meters. So it will be 8 times 10 power negative 2. Okay, like that. So this one is positive, and then plus, we're going to take the moment for this force, which will be, so plus 0.60 times, so this will be 38, because we have 8 and then we have 30 there. So 38 times 10 power negative 2 minus the moment, so this one which is going in that direction, the moment for X will be 12, or X times 12 times 10 power negative 2. So all this has to equal 0. We can put our 0 here. So 0 is equal to this. Okay, so here we're going to have let's punch on the calculator. On our calculator there we have 0.25 times 8 times 10 power negative 2. Yes, what do we have there? Okay, so this will be 0.2. So we have 0.02 rather. So 0, you can write out 0 there, no problem. So 0.02 plus, let's have the other one, plus 0.60 times 38 times 10 power negative 2. Okay, so we have 0.228. So here we have 0.228. Okay, plus minus minus, let's just punch this on the calculator as well. So we have 12 by 10 -2, so that we get the okay. So here we're going to have 0.12, 0.12 x. Okay, so we're going to take, we solve for x, so we have to take x that side, so that we are going to take 0.12x that side, so that we have positive x. So here, so negative, when negative crosses the equal sign, it's going to be 0.12x is equal to 0.02 plus 0.228, and then whatever we have, we'll divide by 0.12, even on the other side 0.12, so that we remain with x. So our x will equal, so let's see this, so 0.02 plus 0.228, which is that, and then we divide 0.12. Okay, so we have 2.1 newtons, so approximately 2. So this is our x. So let's look at part D. So part D says, first of all, let me just grab this. Okay, so part D says an electric pump pushes 5 times 10 power 6 cubic meters of water in 10 minutes through a height of 15 meters up to a tank. Take density of water to be 1000 kg per cubic meter. Okay, so this one, question 1 says calculate its power. Okay, so maybe we can draw a scenario. So we have a tank at a height, and then we have water there that is being pumped. So this height is 15 meters, and then we have a pump. Okay, we have a pump which is coupled to an electric motor. Okay, let's draw. Okay, so we have a pump and an electric motor there. Okay, something like that. So here we have water that is being pumped from here. So this is 15 meters there. Then calculate the power. That is what the question says. So we know that power is equal to force times velocity to start with. So power is equal to force times velocity. And what have we been given here? We've been given the volume. So we have the volume of water. Volume is equal to 5 times 10 power 6 cubic meters. Okay, what else have we been given? We've been given the time. So we have time, which is 10 minutes, which is the same as 10 times 60 seconds. So this is 600 seconds. Okay, and we also have the density, rho. Okay, we can write the density here. Rho is equal to 1000 kg per cubic meter, and we can also put the gravity. We know that G is equal to 9.8 meter per square second, like that. Okay, so from here we know that the force F is equal to the weight, because water is being pushed upwards, meaning it's going against gravity. So the force that will be acting is the weight. The force that we'll be dealing with is the weight, which is the mass times the gravity. So the weight, which is equal to mg. Okay, and then the velocity v is given by distance over time, but we know that the distance that we are covering is 15, which is the height. So it will be height over time, like that. Okay, so our equation for power there, our power equation will be the force is the weight, which is mass times gravity. So it will be mass times gravity, and then times velocity, which is h over t. So times height over time. Okay, so power will equal mass times gravity times h, everything over time. So what we do not have is the mass, but we can find the mass using the density and the volume. We know that rho, or density, is equal to mass over volume. Mass over volume, and we have the density and the volume there, so we can make mass the subject of the formula. So mass will equal density rho times v. So our mass will be, our density is 1000, and our volume is 5 times 10 power 6. So this will give us the mass of 5 times 10 power 9. This is in kgs. So this is what we're going to use there. So our power equation will be, let's write it here. Power is equal to the mass, which is 5 times 10 power 9, times gravity, which is 9.8, times height, which is 15. Height is 15. So let's confirm. So the height is 15 here, so which is 15 over time, 10 minutes, which is 600 seconds. So time has to be in seconds. So 600. Okay, so let's punch that on the calculator. So we have 5 times 10 power 9 times 9.8 times 15. Okay, so that, then divide 600. Okay, so we have that. Okay, so we have power equal to 1 okay, so this is in watts. So this can also be rewritten as 1225 times 10 power 6 watts, which is so this is in megawatts, because 10 power 6 would be megawatts. Okay, so that is our power there. And then the last part says describe the energy changes from the pump to the water. Okay, so here we know that the pump is powered by an electric motor. It is coupled to an electric motor. So from here we know that this is electrical, and then at this point where the pump is, we have mechanical. So electrical energy, mechanical energy, and then here, since water is moving upwards like that, so here we are going to have kinetic, and then when water reaches the tank, we have potential. Okay, so we have electrical energy, mechanical energy, kinetic energy, and then potential energy. So if it's from the pump, then it is starting from mechanical, kinetic, and then potential on top there. Okay, so that's it for this video. Thank you so much for watching.